This conference will now be recorded.
All right, this is a Math 211 video on section 2.3. We had 3 examples left at the end of the notes from that day. Starting with example 9, it says, suppose that f of 4 is 2, g of 4 is 5, f prime of 4 is 6, and g prime of 4 is negative 3. So these are all just different, remember, ordered pairs that would be either in the functions or in the derivative functions. It says find h prime of 4 when h of x is g of x over f of x plus g of x. So the first thing we should probably do is find the derivative of h of x, because that is what we're going to be plugging 4 into in just a second. So because it is a rational function, essentially functions on top of other functions, we're going to use the quotient rule. So the top is g of x, so top prime would be g prime of x, since we don't even know what the function is. The bottom is f of x plus g of x, and so the prime of that would just be f prime plus g prime, since derivatives can be taken of a sum. So then when we go to work out our quotient formula, remember that we have to do bottom, which is f of x plus g of x, times derivative of the top, which would be g prime of x, minus top times derivative of the bottom, which would be f prime of x plus g prime of x, all over the bottom squared. Now remember, each of these is going to be just the 4 once we plug in the h prime of 4. So essentially all we're doing is looking up here and finding the values that each of those would be if they were evaluated at 4. So h prime of 4 is going to be, we'll have a parentheses, f of 4 is 2, g of 4 is 5, so 2 plus 5. G prime of 4 is negative 3, so we'll need to work that out in a second. G of 4 is 5, f prime of 4 is 6, plus g prime of 4, which is negative 3, all over f of 4, which is 2, plus g of 4, which is 5, squared. So this is just order of operations at this point. So that would be 7 times negative 3 minus 5 times 3, all over 7 squared. That is negative 21 minus 15 over 49. That's going to be negative 36 over 49. So there is h prime of 4. Now for number 10, this is a working backwards problem. Essentially, they've given us the ordered pairs for the function at 2, the derivative at 2, and the second derivative at 2. And it wants us to find the original polynomial that would meet all of these conditions. And it has to be a second degree polynomial, which means it is essentially like a trinomial. That's what we're going to assume. So we're going to just kind of set up parameters for what we would think the original polynomial looked like. So we don't know its coefficients, so we're going to call it ax squared plus bx plus c. That's a generic second degree polynomial. Then the derivative of this we can take just from using these generic variables. This would be, and remember we're taking derivative with respect to x. So this would be 2ax plus b, because the derivative of x is just going to be the coefficient in front, and the constant's derivative is 0. F double prime would then be just 2a, because that's the derivative of the first term, and the second term's derivative would just be 0. Remember, a, b, and c are just coefficients here. So we're going to backtrack starting with the second derivative. So if f double prime of 2 equals 2. Now notice this says when x equals 2. So since there is no x in this function, we're just going to set the 2 equal to 2a because the x plays no part here. So if we solve this, we'll find out that a is equal to 1. So we know the first part of our second degree polynomial is that it has a 1 in front of its x squared. Then what we can do is we can plug that in for the next level up. So f prime of x, 2 times 1 would just be 2x plus b. Now we're going to use this equation. So f prime, and I guess we should have called it p, but I'm going with f. So f prime of 2 is equal to 3. Now this time, again, we are plugging in 2 for x, so we do have something we can plug in here. So 2 times 2 plus b should equal the 3. So that's 4 plus b equals 3, or b equals -1. So now we know our second coefficient in front of x. And you can guess for the third step, we go up to the original function and we're going to plug in the a and the b that we've both found, and we're going to find c. So f of x is, a was 1, so it's going to be x squared minus x, but we don't know c. And we know that f of 2, or p, since I changed the name, is 5. So remember, this is what we're plugging in for x. So this is 2 squared minus 2 plus c equals 5. So that's 4 minus 2 plus c equals 5. That's 2 plus c equals 5, or c equals 3. So positive 3 is the last part of that function we were looking for. So we should call it p of x for all of these, obviously, since they said to call it p. Find an equation of a tangent line to the curve y equals x to the 4th plus 1 that is parallel to the line 3x minus y equals 15. Okay, so the first thing I know is that tangent lines mean I'm going to need a derivative. So I'm going to go ahead and take the derivative of that function. That would be 4x to the 3rd. Now, I want it to be parallel to this line, so I need to know the slope of this line. So if you imagine solving that over, we would subtract the 32x over, then we would divide everything by -1. So that's going to make it 32x minus 15. This is the slope that we want to be parallel to. And remember, parallel means same slope. So you have to remember that this is telling us that our slope needs to still be 32. Remember, this stands for slope. So we can solve this. This is 32 equals 4x cubed. Divide by 4, that would be 8 equals x cubed. So x equals 2, because we're taking the cubed root there. So now we already know the slope. So the slope is 32. That was defined by the line being parallel. The other thing you need for an equation is an ordered pair. So since we were able to solve for x, we should be able to plug it back in and find the appropriate y, but we need to plug it into our actual function that we're finding the tangent line to. So this is 2 to the 4th plus 1. That's 16 plus 1, which is 17. So I'm using the slope of 32 and the ordered pair to 17. So y minus 17 equals 32x minus 2. That's y minus 17 equals 32x minus 64. We add 17 over. And I don't have a calculator handy, so I'm going to do that by hand. We're actually subtracting the difference. It is going to be 47. So y equals 32x minus 47. Notice that is parallel to this other line. It has the same slope but a different y-intercept. And it is tangent to this line at the point 2, 17. All right, that's the end of that video.